simultaneous equation 6. Now in this case we've got a coefficient of x or y, and in this case we've got one of each, which is a fraction. Okay, let's see how we would deal with this. The first of all, we have to try and make one of the coefficients the same, and so the best plan here would be to, let's call that number 1 and we'll call that number 2, would be to get rid of the fraction in both cases. So if we times the top one by 3, we will end up getting rid of the thirds here. So if I multiply 2/3 by 3, I end up with just 2x. Don't forget to times everything else though, so we got 3y, and 3 times 16, 48. And then to get rid of the y over 2, which is the same as half y here, I'm going to times equation number 2 by 2. So we will have 2x, all of it gets times, don't forget, plus y equals 28. Now we're going to call these equations 3 and equations 4. Now we can see now that we have a match. If you didn't have a match at this stage, you could go ahead and say double the top row or whatever you'd need to do in order to make your match. But we do have a match now, so we can just go ahead and subtract. So 2x minus 2x is nothing. 3y minus y is 2y. 48 minus 28 is 20. Divide both sides by 2 and we have y equals 10. Now we're going to put the y equals 10 back in. Now it's probably better in this case to not use one of the top two, because then you can avoid using those fractions. Maybe I'm going to put it into equation 4. So 2x plus y equals 28. You can put it into any one that you like. It will work whichever way you do it. So if y equals 10, that's going to be 2x plus 10, replacing the y with a 10, equals 28. Subtract 10 from both sides and we have 2x equals 18. Divide both sides by 2 and we end up with x equals 9.